All right, page 52 in your textbooks as we get started. I was going to try to look at these yesterday and said, we'll hold off for another day. Read word problem 26 on page 52 for us, if you would. Kirsten?
26?
Yes.
Mrs. Lucas bought 6 3/5 yards of silk material. She used 2 4/5 yards of material to make a blouse for her daughter Isabella. How many yards does she have left?
All right, what are we going to have to do to figure out how much cloth, how much silk remaineth, Kirsten?
Subtract.
We're going to have to subtract. But in order to subtract fractions, class, you got to have a common denominator. For that matter, to add fractions, you got to have a common denominator. And to multiply fractions, you got to have a
Common denominator.
No, you don't. Not to multiply. Just to add or subtract. I tricked you. I know. I'm mean like that. I shouldn't be that way. All right, at your seats. Go ahead and do the subtraction. Number 26. Find out how much material Mrs. Lucas has left now that she's made her daughter's blouse. Nice thing is, we already have, class, our common denominator. So all we got to do is say, what's 3/5 minus 4/5?
What?
Wait, we can't do that, can we? Don't fall into the trap of trying to say, well, 4/5 minus 3/5 then. No, that's not how it works. You've got to do what in order to subtract a smaller from a greater from a lesser, class? You've got to borrow. So we're going to borrow from the 6, make it a 5. And the one that we borrow, what does it become, class? 5 more fifths, which gives us really 8/5. Lazy. And then we can do our subtraction. And what do we get, Kirsten?
3 4/5.
3 4/5. And the question said, how many yards does she have left? Since it used the word yards in the question, I don't have to use the word yards in my answer. But if it had said, how much cloth does she have left? I would have to specify yards. If you want to be on the safe side, just plan to put the unit with your answer on word problems. How many had 3 4/5 yards as your answer, or 3 4/5? Questions on that? Questions on the borrowing? Yes, Michael?
To the point where you said that you have to put like yards at the end of a problem. Like for example, if someone said if you subtracted a number from gallons, would you have to put?
You'd use gallons, whatever unit would be there. Yep. Unless the question uses the term in it, then I'm not a stickler because I feel like if I said, how many gallons do I have? 2. That's very clear, right? But if I said, how much water do we have? And I just said 2 what, right? So I'm very literal on those things. But anyway, in this case, 3 4/5 would suffice as our answer. Take a look at number 27 and read that one for us. Speaking of gallons, Michael, read number 27 for us.
Mr. Allen's car has 13 gallons gas tank. To fill the tank, she needs to purchase 6 3/4 gallons. How many gallons were in the tank before refilling?
This is always a curious thing. How many of you, your parents wait till the light dings on and tells them they got to go fill up? All right. And so I usually try to do it if I notice, hey, the gas station price went down. Do I need gas? I'm at half a tank. I'll go ahead and fill up. I try to do when I see the price is low. And apparently it's kind of what she did. But sometimes, it dings and you just keep driving. And you're living on borrowed time. And you just keep driving and finally okay, I need to stop living on borrowed time. So you pull into the gas station. I'm always kind of curious, how close did I cut it? So when I fill up, I know how big the gas tank is. I think mine is also 13 gallons in my CRV. And so I'm curious, when I fill the tank, if I'm putting in 12.5 gallons, I came down to about half a gallon worth of gas. I'm cutting it close. That probably wasn't too smart. But anyway, that's what she's got. She put in 6 3/4 gallons. How many gallons were already in the tank when she filled up? What are we going to have to do here, Michael? Once again, we're going to have to subtract at your seats. Do your subtraction. Let's find the answer, number 27. And here, we're we're trying to subtract 3/4 from no fourths. So once again, what do we have to do, class?
Borrow.
So we're going to make our 13 become a 12, and the one we borrow is going to become a 4/4. And then when we subtract, what do we get, Michael?
6 and 1/4.
And it did say in the question how many gallons were in the tank, 6 1/4. But if you wanted to be on the safe side, if it said how much gas was in the tank, then you have to say 6 1/4 gallons. All right, how many had the 6 1/4? All right, questions on that? Yes, sir.
I asked, but do you dock points if we don't put it?
If it had asked how much gas was in the tank, and all you say is 6 1/4, I'm like 6 1/4 what? But since it said how many gallons are in the tank, there's no question what you mean when you say 6 1/4. So no points off on this if you just put 6 1/4.
Well, how about, would you take off points if it didn't say it?
If it just said how much gas was in the tank,
Yeah.
and you put 6 1/4,
Yeah.
yeah, minus a point. Yep. Good. All right. Flip back to page 49 for just a moment. Flip back to page 49 for just a moment. Want to look at the example problem at the top of the, or top middle of the page. Example 1.10c. We actually looked at this problem yesterday. We looked yesterday at multiplying, specifically multiplying with cancellation. And remember we said you can't multiply mixed numbers. You can add and subtract mixed numbers. You have to have a common denominator, but you can't multiply mixed numbers, though you don't need a common denominator. You see each one has its pluses and minuses? So looking at example 1.10c on page 49, notice they changed the 4 1/2 class to, it's right there already in the book. 9/2, thank you. And the 1 2/3 became, and notice they said, well, I can cancel the 9 and 3. Do you see where they got the 3 and 1? And then we just multiply across. 3 times 5,
15.
2 times 1 is,
2.
but they couldn't leave 15 halves, so they changed it to 7 1/2. Do you remember doing this yesterday? All right, back to page 52 then. Do numbers 28 to 36 even. 28 to 36 to even. Let's practice a little bit more with multiplying and canceling. Michael and Elaine already finished. Luciana? Finished or thinking? Finished. Bryson finished. Got some fast mathematicians in here. You know why mathematicians are fast? Because they're lazy. They don't want to spend all day doing math. They want to be fast to get it over with and watch football. Or basketball, okay. Any tissue? All right, let's take a look at these together. Number 28. Does anything cancel, Sam? Nope. So we just multiply across. What do we get? 21 55ths is correct. Number 30. Does anything cancel, Bryson?
Yes.
Yes, the 4 and 2. So what's our answer?
2
2 7s. Now, could you just multiply and get 4 14ths and then reduce? You could. Why? It's more fun to cross things out. Number 32. Can we cancel anything, Luciana?
Yeah.
We can cancel a bunch of stuff, can't we? We can cancel the 4 and 16 to get what? 1 and 4. And we can cancel the 9 and the 18 to get what? 2 and 1. And for that matter, class, we can cancel the 2 and the 4 to get what? 1 and 2. So when I multiply across, Luciana, what's my answer? 1/2. How many have 1/2 for number 32? How many got 2/4? forgot to cancel the 2 and 4. All right, number 34. What do I have to do with the 12, Corey?
You have to multiply it.
Well, but before I can do that, what do I need to do with the 12? Because it's got to be a fraction, right?
Put it over.
Put it over 1. What can I cancel?
No.
Nothing. Don't cancel numerators with each other. Any numerator with any denominator, but not a numerator with a numerator. So we just got to multiply across to initially get.
48 over 5.
But we don't leave improper fractions. We changed our answer to
9 and 3/5.
9 3/5. Great job. Number 36. We can't multiply mixed numbers like that. So Paige, we had to change 1 and 1/12 into
13 over 12.
13 12. And what can we cancel here, Paige?
4 and 12.
4 and 12 to get
1 and 3.
1 and 3. And there is something else. Did you see it? What is it?
13 and 26.
How many realized you can cancel 13 and 26? We didn't learn our 13 times tables, but hopefully a lot of you saw 13 and 26 Paige can cancel to give you
1 and 2.
1 and 2. So our easy answer is
1 over 6.
1 over 6. Aren't you glad we didn't have to multiply it like this and get 52 312ths and then figure out how to reduce that? Canceling saves you so much work. How many got the 1/6? How many got all 5 of these right? Questions on any of those? All right. Let's look down now at page 49 again, and let's talk about division of fractions. Division of fractions. Now, the book points something out here. If I were to take 32 and divide it by 4, that's something we memorized when we were in 3rd grade. Chloe this year is going to learn 32 divided by 4. Class, what is 32 divided by 4? 8. If I were to multiply 32 times 1/4, we would say that I need to put the 32 class over
1.
and then I could cancel the 32 and 4 to get 8 and 1, and I would get 8. It's the same answer. If I were to have 2 pizzas, and I said, let's see, I know that junior high guys at least need a half a pizza just to be full, right? I mean, Ben's not going to be full if I give him one lousy little slice. Boy needs a half a pizza. Keep him filled up. Give him strength and energy for his 12-minute run on Friday, right? So not like scant minutes before the 12-minute run. You don't want to eat a half a pizza, but a few hours before is a good time to eat a half a pizza, I suppose. And so I would decided to divvy up 2 pizzas, giving guys half a pizza each. How many pieces of pizza? How many servings is that, class? 4, because 2 divided by a half is 4. Well, that's the same as saying that there's 2 slices per pizza, and there's 2 pizzas, so 2 times 2 equals 4, right? And this is why division of fractions is the same thing as multiplying by what we get if we flipped that second fraction. 32 divided by 4 could be replaced by times 1/4. 2 divided by half could be replaced by 2 times 2. So in your book, you see that where it says, you see the term reciprocal. You actually see it in red on this little shaded box here. Mark that term reciprocal. And I want you to write this statement in your notes. Your book kind of alludes to it, but doesn't come right out and say it like I'd like you to see it. To divide fractions, multiply by the reciprocal. To divide fractions, multiply by the reciprocal. Because let's face it, we want math to be easy because we are lazy. We know how to multiply fractions. We're good at multiplying fractions. We just did it and we did great. Why would I want to learn a whole new way to divide? If I could just make a division problem turn into something I already know how to do. Does that make sense? So to divide fractions, class, multiply by the reciprocal. All right, say it again. To divide fractions, multiply by the reciprocal. Now, here's the key. Reciprocal means you flip it. Okay? Reciprocal means flip. And you see in the blue shaded box that I pointed to a moment ago with the red reciprocals, 3/4 when you flip it, class, becomes 4/3. 1/3 when you flip it, class, becomes 3, or 3 over 1. And if you flip a 10, well, remember, 10 is technically 10 over 1, so if you flip it, class, it becomes 1 over 10. Does that make sense? but we're going to multiply by the reciprocal. Here's the key. You flip the one after the division sign. Might want to write that down. Flip the one after the division sign, because every year I get young people, whether it's in summer school where I've worked with elementary kids and junior high kids, or even in my 8th grade math class that I've taught the last few years, get a kid who tries to flip the first one. We don't flip the first one, we flip the second one, the one after the division sign. So flip the one after the division sign. Write that down. So when we see, for instance, example 1.10b, 3/4, and it says divided by 3/8. Well, we're not going to divide by 3/8. No, we don't do that here. Instead, we're going to change this to a multiplication problem. And class, we're going to multiply 3/4 by 8/3. We're going to flip the second one. And now we can do all the same stuff we did a second ago. We can cancel the 3's. I'm not even going to waste my time writing 1's. I can cancel the 4 and 8 to get 1 and 2. And so my answer is 2 over 1, or just 2. All right, questions on that? Turn the page. Oh, mixed numbers. Class, are we allowed to multiply mixed numbers? And when we divide, we're really still just going to multiply, right? So if we see a division problem, our brain says we're multiplying anyway. So can we divide mixed numbers? No, because we can't multiply, but really division is just multiplication by the reciprocal. So the 6 2/5 class, they changed to get 32/5. We're at the top of page 50. Follow along with me. And for now, I'm going to leave the division sign, and their 2 2/25 became 52/25. But we don't divide fractions, class. What do? Multiply by the reciprocal. Class, we don't divide fractions. We do what?
Multiply by the reciprocal.
And reciprocal means we flip it. Which one do we flip?
The right hand.
The one after the division sign. The one after the division sign. So I'm going to keep the 32/5. Don't flip that one. Just multiply and flip. I've heard some people say this. Keep, change, flip. How many have heard that? Keep it, change it, flip it. Keep it, change to multiplication, and flip it, class. So it says 25 52s. There we go. And 50 seconds, whatever. We can obviously cancel the 25 and 5, class, to get 1 and 5. 32 and 52. Well, they're both even, right? So that means at least I can knock out a... What do I get if I knock a 2 out of a 32? 16. What do I get if I take a 2 out of a 52? 26. Hey, they're still both even. I can take out another 2. Let's take a 2 out of a 16.
8.
Let's take a 2 out of a 26.
13.
Yeah, that's all I can take out. All right, so now let's multiply across. 8 times 5? 40. And 1 times 13? 13. How many times would 13 go into 40? 3 times. What is that, by the way, class? 39. So it goes in 3 times, almost exactly. There's just 1 left over. So we'll say 3 and 1/13. And there's our answer. Questions on dividing fractions. Does that make sense? All right, not trying to insult your intelligence or anything now, but look over at page 52, and I'm going to insult your intelligence a little. For numbers 37 to 44, all I need you to do is find the reciprocal. Don't make this too hard now. So do 37 to 44 and just tell me what is the reciprocal of each. Reciprocal, of course, class, means you flip it. That's all you have to do. Now, admittedly, the mixed numbers get a little dicey, but for the most part, this is insultingly easy. Yes, sir.
Do you have a water cabinet or something?
No, I bring them from the bag from home. First, you make it a mixed number or an improper fraction. All right, number 37. I'm not trying to make you feel stupid here, but class, what's the reciprocal of 7/8? 8 sevenths. That shouldn't have taken but about a half a second to write down. What's the reciprocal of 2 11ths? 11 twos, not 11 halves. 11 halves. What's the reciprocal of 1/9? 9. Or 9 over 1 if you want to put it over 1, that's fine. What's the reciprocal of 1/15? 15. Or 15 over 1 if you want to. What's the reciprocal of 14? 1/14. What's the reciprocal of 23? 1/23. Number 43 did require a little work, because first you had to make it an improper fraction. What's the improper fraction, Griffin, for number 43 initially?
21.
Well, 41...
41. 9.
Nice, there we go. So what's the reciprocal, Griffin?
940.
First. 941. 941st is correct. And number 44, we also had to first make it improper, Elaine.
And 41, wait, which one?
Number 44, follow along with me.
83 over 11.
Oh, 83 11ths. And then we can take the reciprocal.
11 83rd.
11 83rds. Good. 11 83s. All right. Questions on those? We all good with reciprocal? All right. So the first fraction, keep it. Second thing, we changed division class to multiplication, and then we flip the 1 after the division sign, right? Multiply by the reciprocal. Okay. By the way, notice the spelling on reciprocal. Reciprocal. Okay. That's how you spell that. All right. I want you to do now numbers 46 to 52, the even. 46 to 52, doing the even numbered problems. Just the even numbered problems, 46 to 52. Several people already finished. Take about 30 seconds longer. I am too lazy to write 46 on the board, considering we ain't gonna do that anyway. So, Elaine, how should I write number 46 on the board?
7/12 times 10 over 6.
There we go. And I look to see what can I cancel and what can't I cancel, Elaine?
10 and 12.
To get?
5 and 6.
Ooh, can I cancel the 6's, class?
No.
No, they're both denominators, 40 feet down. So we just have to multiply. What do we get for our answer, Elaine?
35 over 36.
Good, 35, 36. Number 48. Then I'm not going to waste my time writing that problem on the board. I'm going to write down something a little different. Ben?
46.
For number 48, then. We just did 46. Pay attention. What do we put for 48? What do I write down?
3 over 8 and 1 over 12.
Times 1 over 12. There we go. Well, what can I cancel then?
3 and 12.
By the way, class, can I always cancel something? No, but always look, right? We do not always be able to cancel, but I can cancel something here, Ben, to get
1, 4.
1 and 4, so what do I get for my answer?
1 over 32.
Good, don't try to cancel that 8 and 4, they're both denominators, we get 1 over 32. Number 50, how should I write it, Kirsten?
5 sevens times 1 fifth.
What can I cancel?
The 5 and the 5.
To get,
1 and 1.
so I get,
1 7.
good, number 52. Ooh, initially, what do I need to write down here, Michael? Because I don't do mixed numbers, that's not what I do. Not for multiplying and dividing.
1 and 1/8.
No, I don't write 1 and 1/8. What do I write?
9 over 3.
9/8, there we go. And I'm going to go ahead and keep the division for just a moment while I work out these annoying mixed numbers. What's the other one?
Okay. 6 and 35.
Well, initially 35/16ths, but yes, when I go to multiply it, I'm going to change it to 9/8 times, flip it, 16/35. I can cancel a little bit here.
8 and 16 to 1 and 2.
And so my answer,
18 over 35.
and there we go. How many on all 4 of them right? You went 4 for 4 on these division problems. Are there any questions now that you've seen them worked? Anyone say, I'm still a little fuzzy on this division thing. Do you see it's really what we were doing before? Same song, second verse, just a little harder because you have to flip something first. That rhymes. Should be a poet. Anyway, questions on it? Maybe not. Okay. All right, I want you to go back into the odds now. Do the 45 to 53 odd. So you've had a chance to make a few mistakes possibly. That's okay, as long as we learn from them. Now let's see if we can clean up the mistakes in 45 to 53, the odd. Luciana, Michael, Ben, Corey and Elaine, take about 30 seconds longer to be finishing up. Number 45, what did you get for your answer, Luciana? 4/5 is correct. Number 47, Sam. Okay, you're not necessarily wrong. I know you did the right thing in flipping to get 10/3 and you canceled the 3s, but there's a little more that could still cancel. And for that matter, even after you get your answer of 10/15, there's something you can divide out of top and bottom. Think of your divisibility rules. Numbers that end in 5 and 0 are divisible by. So let's divide the 5 out of the top and bottom to get 2/3. There we go. So final answer, 2/3. Number 49, what did you get for your answer page?
36.
36. Number 51, what did you get, Ben?
1 and 1/10.
Ooh, close. But Corey?
1.
Just 1. Came out evenly to 1. Take a look at this. You get 10 ninths, right? And initially you get 20 18ths, but then you have to flip it, right? Make it 10 ninths times 18 20ths. So far, so good, Ben? Oh, no, maybe not. Okay, so we cancel the 10 and 20 to get a 1 and 2, right? We cancel the 9 and 18 to get 1 and 2. And then the 2 and 2 also cancel, class. So all I've got is 1 over 1, which is?
1.
In other words, if everything cancels, your answer is 1. Remember to write that down across the top of the page. If everything cancels, your answer is 1. Only because if you're not careful, you're going to be like, oh, I canceled everything. I get a 0. No. You technically have 1s everywhere, which gives you a 1, not a 0. So be careful with that. Number 53, what did you get for your answer, Griffin?
1 and 1/2.
1 and 1/2 is correct. Anyone need to see any of these worked? I know I've worked a couple of them on the board, but others we need to see worked out. How many went 5 for 5? You went 5 for 5, you got them all. All right, questions on any of these? Going once on questions. Twice on questions. Flip back to page 50. Now let's talk a little bit about complex fractions. And I think this might be new to you. Did you learn about complex fractions in 6th grade? Doesn't it sound terrifying? Like you're like, fractions already, nobody's favorite, but then complex fractions. It's really not that bad. Here's what a complex fraction is, and you see it there. A complex fraction, see it there in bold, is a fraction that has a fraction or mixed number for the numerator or denominator or both. Here's the way I like to put it. A complex fraction, get it out of your mouth, Corey. A complex fraction is a fraction with fractions in it. Let me say that again. A complex fraction is a fraction with fractions in it. So for instance, you see an example there. They have 1/2 tenths. That's a complex fraction because the numerator is a fraction. You see another example there. Make sure you're following along with me, Paige. 1/2 3/5. Okay, both numerator and denominator are fractions. Or 3.5 4 3/5. That's also a complex fraction. Does that make sense? But here's the key. We already know this because we studied order of operations. What does a fraction bar actually mean? Kirsten? Divide. Write this down. Or next to where it says, right here, you see a little yellow thingy that says complex fractions. Write this down next to it. Division problem. That's all it is. It's a fancy way to show division. Nothing more. Write that down. A complex fraction is a division problem. But for some reason, instead of using a dot/dot division sign, they've decided to use a fraction bar. Look at the example problem. They have 2/5 over 6/20. Right? This literally means, class, look and listen, 2/5 divided by 6/20. If I wanted to, and I don't, because I'm lazy, I could write it 2/5 divided by 6/20. I could do that. It's the same thing. They mean the same thing. Does everyone understand that? Because a fraction bar, class, means divide. And so therefore a complex fraction is a division problem. Did you write those two words down? Division problem. Do I ever really divide fractions though, class? No. What do I do?
Multiply by the reciprocal.
Thank you, Elaine and Chorus. Class, what do? I don't divide fractions, I
Multiply by the reciprocal.
multiply by the reciprocal. So when I see this, I see this as 2/5 divided by 6/20. And I say to myself, I don't do that. I don't divide fractions. So instead of dividing by 6/20, class, I'm going to multiply by 26. I skip this step because I'm too lazy, and I go straight to this one. Here's the key. Remember, I said you always flip the second one. First, second. Everyone got that? Like if we were writing the top students in the 50-yard dash yesterday. I don't remember who they were. Michael pulled up short because he had a leg problem.
I had the fastest time. I had 0.
But if we were writing it down, we would all assume the number 1 student would be listed first, then the number 2 student, and number 3, and so forth, right? This is first, this is second. We flip the second one. That one flips, all right? So there's no question, because it's technically after this division sign. And then go back to what we just did a minute ago. We canceled 2 and 6, class, to get
1 and
1 and 3. We canceled 20 and 5 to get
1.
4 and 1. And then we multiply across to get
4/30.
4/3. And then we change it to a mixed number to get
1/30.
1 and 1/3. So complex fractions aren't hard. Nothing wrong with complex fractions. It's just instead of writing them this way, somebody thought it'd be a good idea to write them this way. But they're the same thing. Either way, we don't divide here. Not fractions anyway. We multiply by the reciprocal. Look at the next example right below it. They had a 1/3 divided by 12. By the way, notice I didn't read 1/3 over 12. Did you hear what I said? Say it with me, class. 1/3 divided by 12. Do we divide fractions? Mm-mm. We multiply by the
Reciprocal.
So I'm really lazy. I'm going to change this to 1/3 times, not 12. Not 12 over 1, class, but the reciprocal
112.
112. And what that is?
136.
We're done. Let it be easy. Even if you saw something ghastly, like you see here in the red and blue, 3.5 over 4 3/5. Well, I don't think of it as 3.5 over 4 3/5, because I think of this as 3.5 divided by 4 3/5. So I change this to say 7/2, and I'm not going to divide because I'm going to multiply by the reciprocal. Well, first of all, what is this? 23/5. So I write, does anything cancel?
No.
No. What's 7 times 5 then?
35.
What's 2 times 23? 46. Good job, Bryce and Hernan first there, and there's our answer, right? Don't let complex fractions make you scared, right? I talked to people, I don't understand what to do. It's a fraction, there's more fraction. It's just a division problem. We don't even do that. We multiply by the reciprocal. Let it be easy. Any questions? Let me have you give some of these a try. Back to page 53. Back to page 53. I want you to do 54 to 64, the evens. You do 54 to 64, the evens, there on page 53. Changed it to that. Yes, yeah. So you can cancel. So you get a 16 and 12. Now you can do 1 out of both 16 and 12. Or you can do better too. You could get out a 4, take the 4 out. Take just about 30 seconds longer to be finishing up, and then we'll take a look at these together. I hear the cry of a forlorn K3er. When I used to hear those noises, I would say, "Oops, sounds like one of our 7th graders is unhappy." But see, now I have the 7th graders, so I can't make those jokes. I was talking about last year's 8th grade. This year's 8th graders, of course, when they were 7th graders. That's what it was. All right, let's go ahead and take a look at our answers here. Number 55. I am not going to write, or 54, excuse me. I'm not going to write 54 on the board. Not the way it's written. How am I going to write 54, Kirsten?
1/6 times 4/3.
Good. And I can cancel a little bit here to get a 2 and 3. So our answer is 2 9ths. Number 56. I am not going to write that on the board as it is in the textbook. Instead, Bryson, I'm going to write
3 8 times 60. Or 64 times
good. And I'm going to cancel the 8 and the 64 to get,
8
and the 3 and 9 to get.
1 and 9. I mean 1 and 3.
And so my answer initially is,
8 thirds.
but of course we changed that to
2 and 2 thirds.
2 and 2/3 our answer. Number 59. I ain't writing that. What am I going to write, Griffin?
56.
Let's try 58. How about number 58? How am I going to write 58?
9/1 times 3/11.
Good. And I'm going to cancel away the? Correct. Nothing. And we're going to multiply to get?
2 and 5/11.
Well, initially 27 11s, but yes, it becomes 2 and 5 11s. Number 60. I'm not going to write that down. Instead, Paige, I should write
15 over 24 times 32 over 5.
32 over 5. There we go. You said it right. I just wrote it wrong. And of course, I can cancel the 15 and 5 to get
3 and 1.
3 and 1. And in a really perfect world, what times tables are 32 and 24 both on, class? Are 8 times tables. Now, if you didn't see the 8 and you just took out a 2 or a 4, that's fine as long as you kept going. But if we take the 8 out, it saves us a little bit of time. 8 out of 32 gives us,
4.
and 8 out of 24 gives us,
3.
but we're not done canceling yet, class.
3 and
The 3's now cancel, and all I've got left, class, is
4.
4 over 1, or just 4. And let's see, for number 62, I'm not going to write that down. What am I going to write, Corey?
2 7 times 1 over 4.
Good. Of course, we can cancel to get 1 and 2, so our answer is?
1/14.
Now, number 64. I've got to put a little more thought into this one because we got the mixed numbers. The 9 and 1/3 becomes what then?
6.
64. The 9 and 1/3 becomes
2 and 1 becomes 1.
Remember, multiply and add. 9 times 3. Brain freeze got him. Luciana, help him. 9 times 3.
27.
And then add the 1.
3.
So we're going to make this a 28/3. And it's initially over. It says 3 and 1/6. Let me come back to Ben now that the brain freeze is over. What does the 3 and 1/6 become, Ben?
It becomes 6 over 19.
Well, initially 19/6. But you're right. I'm not going to keep it this way because I'm going to change it to a multiplication problem. 28/3 times what you said. Yes, 6 19ths. We'll do a little bit of canceling here to get a 1 and 2. Class, going to cancel the 2 and 28?
No.
No. Got to multiply. 2 times 28. Class? 56 19ths. That's just awful. How many 19s fit into 56?
2.
3.
3.
Almost 3. What's 3 times 19?
57.
57. Missed it by that much, so I'm stuck with 2 of them. How many leftovers? 18. So 2 and 18, 19 is our answer. How many got all the evens correct? 54 to 64. How many got all the ones you did correct? Might be a better way to phrase it. All the ones you did correct, because some of you might not have made it to the last one. Questions on any of them? All right, let's take a look at some word problems now. Flip over to page 54. Flip over to page 54 and look at word problem 66. Read that for us if you would, Sam. Page 54, top of the page, word problem 66.
The recipe for a loaf of canary nut bread calls for 3/4 cup of orange juice. If Sarah has 6 cups of orange juice, how many loaves of canary nut bread can she make?
All right, so Sarah's like, I'm going all in. I'm going to use all the orange juice in this cranberry nut bread recipe. I'm making a lot of loaves of bread. And I don't know that I've ever had cranberry nut bread. A lot of other forms of bread, I don't know. Anyway, every loaf takes how much, class? 3/4 of a cup. But she's got 6 cups to divvy up amongst these various loaves. So what do we have to do, class? Divide. I'm going to divide what, Sam? Which one goes where? Ah, okay, so think of it this way, class. The fractions sometimes complicate life for us, right? But let's suppose she has 6 cups of orange juice, and the loaf takes 2 cups. Well, 2 cups for a loaf, she's got 6 cups. How many loaves could she make, class?
3.
How do we get that? Take the 6 divided by 2. All right, think about a regular, nice, easy number rather than, the 3/4 throws us off, but it's going to be the same thing. It's still going to be the 6, but not divided by 2, divided by 3/4. Does that make sense? So use a number we do recognize. We're going to divide the 6 by 3/4. I say we're going to divide. We're really going to do what, class?
Multiply by the reciprocal.
There we go. So we're going to change it at your seats. Find the answer. How many loaves of cranberry nut bread can she make? Now, that assumes she has all the other ingredients too, because obviously there's more to cranberry nut bread than the orange juice no one would have thought was in there. How many loaves, class? 8. When you multiply by 4/3, do a little cancel, you get 8 loaves of bread. And again, it says how many loaves, so you can just say 8. If it said how much bread can she make, you'd say 8 loaves. Number 67, read that for us if you would, Bryson.
Ashley gave 2/5 of her bonus check of $255 to the missionary family. How much money did she give to them?
All right, so maybe Ashley gets a bonus at work. She gets, after taxes, probably $300. Let me say that again. It was probably a $300 check. After taxes, she ended up with $255. Yeah, that's a lot of tax. That's how it works when you make money. The government takes a whole lot. But she's blessed now, right? She gets this bonus, and then she's in church, and there's a missionary family has a need, and the Lord touches her heart and says, hey, I gave you that bonus check so you can give some money to the missionary. So she says, okay, Lord, I want to do what you want. So she gives 2/5, note the word of. I want you to write this at the top of your paper. When dealing with fractions, particularly, the word of means multiply. The word of means multiply. So when it says 2/5 of her bonus check, class, we're going to take 2/5 times her bonus check, her $255 bonus check. When you're working with fractions, the word of means multiply. At your seats, find out what she gave the missionary. After taxes, she got $255. She gave 2/5 of that, or 2/5 times that, to the missionary. How much did she give to the missionary? We cancel obviously with the 5, can't we? How many times does 5 go into 25?
51.
Well, 5. How many times does 5 go into 5?
1.
So there's a 51, and 2 times 51 gives us
120.
$102. $102 is how much money, don't forget your dollar sign, she gave to the missionary family. Homework for this evening. Homework for this evening, you're going to practice with multiplying and dividing fractions, a little adding, subtracting as well, just to make sure we don't forget that. Page 55, numbers 25 to 50. Page 55, numbers 25 to 50. Page 55, numbers 25 through 50. Once you got the copy down, you are dismissed. Have a wonderful rest of your day.